Hello and welcome to my introductory session. My name's Leon, and today I'm going to be talking to you a little bit about Electron configuration, and then we'll be diving deep into the Electron configuration of Group 2 and how it can affect some of its physical properties. So firstly, some sort of background knowledge and knowledge to be able to approach this topic is firstly the understanding that orbitals exist. So from GCSE knowledge, maybe you understand that there are shells, and each shells of electrons contain 8 electrons. But moving on from that, when we get to A level, we can sort of work on orbitals. So we have namely the s orbital, which contains 2 electrons, the p orbitals, which contain 6 electrons, and so this s and p usually forms this 8 electron shell that we're used to seeing. Then we have the d orbitals, which are from the transition metals, which have 10 electrons, and finally the f orbitals, which we won't really be delving into in today's session. So with this knowledge, we can now have a deeper look at Group 2. Now specifically, I have put up a table here of the electron configurations of Group 2, and you should recognise some of these elements: beryllium, magnesium, calcium, strontium and barium. Let's have a little look about their electron configuration. So firstly, we can see beryllium here. We have 1s2, which is our first electron shell and first electron orbital, the s orbital. Then as we move on to the second electron shell, we have a 2s2 forming here. If you look at magnesium, we have the same 1s2, 2s2, this additional 2p6 orbital, so now we're filling the p orbitals, and finally the 3s2 orbital. And then if you look down and down, if you look for yourselves, we fill in the electrons the same, and we get this additional d orbital forming with calcium, and finally getting 4s2. So one of the first things I always like to ask students is, what do they first realise or notice about the electron configuration going down a group, which is going down the periodic table? So the first thing that you should notice in bold, the outer electron, or the valence electron, is always in this s orbital, whether it's in the second shell, third shell, fourth shell, fifth shell. It's always in this s orbital, and there's always 2 electrons in the s orbital for all of the elements within Group 2. So that should tell you a little bit about why we call it Group 2, because there are 2 electrons in its outermost shell, and not in its within the shells, but only on the outermost shell is what we concern ourselves with when we call it Group 2. From this information, can we now deduce some things about the physical properties, i.e. boiling point, for an example? Well, if we look down to this graph I have here, apologies if it's slightly blurry, as we go down our group, so beryllium, magnesium, calcium, strontium, barium, what sort of trend can we see here? Well, overall, we can see that if we were to just draw a line here, it would be a negative line. It will be decreasing. So as we go down the group, the melting points of our Group 2 elements decrease. So in general, why is this happening? Well, as we have bigger and bigger atoms and elements, their intermolecular forces get weaker and weaker because they get much bigger, and the attraction between the nucleus and the surrounding electrons becomes much weaker, especially held in a metal, and therefore our boiling point decreases. Now you might notice to yourselves, well, what's this little dip here? What is this anomalous result? Well, that can be attributed, if we go back up, to the presence of the d orbital. So as we go from magnesium to calcium, the biggest difference between these two is we have this 3d10 orbital now appearing. So these extra 10 electrons, which were not existent here but now exist here, the extra electron strengthens the intermolecular bonds between atoms and therefore increases the boiling point of calcium. And then the following elements, strontium and barium, also have this 3d10 orbital and 4d10. So now the trend continues as the same number of orbitals are now present. So that is, in summary, a quick rundown of the group 2 elements, and hopefully from this we can now relate electron structure, and we can use the electron structure to explain some of the reasons as to why some of the physical properties arise in particular boiling point. Thank you.